Hello everybody and welcome to our video lecture for test number 2 review. I have a couple of reminders before I get started with the actual review itself. You should have received a paper version of this review in class on Wednesday. If you didn't, you can download it from eLearning and follow along with me as far as the problems are concerned. So a couple other things. First, the test is on Monday. Now, unlike the first exam, there will not be a calculator-free portion for this test, so you'll have access to your calculator the whole time. You will not be able to use a graphing calculator, so please make sure that you bring one that is non-graphing. I will have a couple of spares if you don't have one, but most of you, I hope, have a calculator handy that you can bring with you. There are some forms of arithmetic on this one, so a calculator will be handy and useful on the test. Now, as far as other things, just a reminder that I will have a review on Sunday. So this is the 19th. I'll be back in town. It will start at 2 o'clock p.m. I will go to 4 o'clock p.m. or maybe a few minutes after if I'm still answering questions. It will be in Building 4. On the first floor. I actually think that the building will probably be locked up, so we will be close to the door, and I will watch for you guys coming in and out. We'll be right by the coffee shop there. Like I said in class, coffee shop's not open though, so don't plan on buying coffee there. So that is going to be on Sunday the 19th, and remember that you also have web work homework too. Your paper homework that you received in lab last Friday is going to be due on Monday. So I'll collect that on test day. I will put up a Dropbox, so it will be available by Dropbox as well. Alright, so today I wanted to give you an assortment of the kind of problems you should expect to see on the test. There are a bunch of problems also available on eLearning. I did do a test review similar to the one for test number 1. So do not think that just because we're working these few problems that you are covered and good to go. Please take a few minutes and go through, or longer than a few minutes, and go through the problems that are listed on eLearning as well. There are several of each type of problem there. So the first problem here I have set up says to graph the function using its vertex, axis of symmetry, and intercepts. So I will be asking you for all of these things. So remember that if you have a function that looks like negative 3x squared plus 6x minus 5, and you want to find the vertex, your choice for looking for the vertex is one of two different ways. You can either use the formula, the vertex is equal to negative b over 2a, and then the function at negative b over 2a. Or you can complete the square in order to put it into standard form. So we'll start with this, the vertex formula. In this case, a is equal to negative 3, b is equal to 6, c is equal to negative 5. That'll help us later with intercepts. And so the x-coordinate of our vertex would be negative 6 over 2 times negative 3. Negative 6 over negative 6 gives us positive 1. And then to find the other side of it, then we do f of 1, negative 3 times 1 squared plus 6 times 1 minus 5. And so I get negative 3 plus 6 minus 5, or negative 2. So using this method, I end up with a vertex at the point 1, negative 2. Automatically, once I have my vertex, I have my axis of symmetry. So my axis is the line x is equal to 1 here. We'll go into the intercepts after we graph this using the, in order to put it into standard form using completing the square. So if I were going to put this into standard form, then I can say that I have f of x equal to, and I need to factor out the coefficient -3. So -3 times x squared, and it's going to change the sign, minus 2x, and minus 5. So what I do for the centerpiece is I take this -2 here, I divide it by 2, and then I square it. So -2 divided by 2 gives me -1, squared gives me 1. So what I'm doing on the inside is adding 1. Now remember, what you do, you have to undo. And I'm not actually adding 1, I'm actually subtracting 3. So what I'm going to add on the back is plus 3. Looking at this, I get -3, and the factor itself is forced. So what I have on the inside of the parenthesis is -1. So I have x minus 1 squared and minus 2. If I take the vertex out of this equation, remember opposite sign in with our x, so my vertex is +1, same sign for y. I have minus 2 on the back, so I have 1, -2. Either way, you come up with the same answer for your vertex is the point 1, -2. So if I were to plot that, there's my vertex here. The axis of symmetry gives me some points. Well, that was kind of squiggly, but you get the idea. Gives me some points that I can use. Now it asks for the intercepts, and remember that your intercept for y is always your c term. So my y-intercept is when x is equal to 0, so I have 0, -5. And I have a point right here. Conveniently, because of my axis of symmetry, I also get another point on the opposite side, so I have one here. Now here's the point in class where I'd be asking you if we needed to solve for x-intercepts. So given the fact we have a negative quadratic, and that means it opens down, I have a vertex below the axis, means that I don't have any x-intercepts. So if I were to draw this in, it looks something like that. No x-intercepts there. All right, moving on. You will have a quadratic function that you have to solve like this. Moving on, solve the problem. Consider the quadratic model h of t is equal to -16t squared plus 40t plus 50 for the height in feet h of an object t seconds after the object has been projected straight up into the air. Find the maximum height attained by the object. How much time does it take to fall back to the ground? Assume that it takes the same time going up and coming down. Alright, so we are launching it from the ground, and really you have, if you have ground level here, it says it's going straight up. So we're going straight up, and then it's going to reach some maximum point and then head straight back down. Now if I were to turn this to a side view, then what you really have is that it gets to the top and then it turns back around. So it's asking you what the maximum height is. Remember that when we are talking about a quadratic function, the maximum of something or the minimum of something, if it opens the other way, is a disguised question looking for the vertex. So this is in terms of t, in terms of time for our input variable, and in terms of height for our export variable, or a variable we're taking back out. So if I'm looking for the vertex here, the piece that I'm actually looking for is the h variable, or the output variable. So if my t is -b over 2a, and here a equals -16, b is equal to 40. So the amount of time it takes to get to that maximum height would be -40 over 2 times -16, or -40 over -32. Looking at that, I have both, let me see what we get for a decimal, 40 divided by 32, 1.25 or 5 over 4. So 1.25 seconds. And usually we'll list a decimal if we're talking about seconds like this. It's also 5/4 seconds. Either way, fine with me. Now the actual height it achieves is the amount of h you get from that 1.25. So if I'm looking for the height, what I have is h of 1.25 seconds, and negative 16 times 1.25 squared plus 40 times 1.25 plus 50. Using my calculator for this, I get a maximum height of 75 feet. So then it asks how much time it takes to fall back to the ground. Now, if we are starting with a parabola and it takes 1.25 seconds to go from the ground to its maximum height, then it also takes 1.25 seconds to reach the ground again. So it would hit the ground in 2.5 seconds after you shoot the thing from the ground. All right, that's what you should expect for actual quadratics. After quadratics, we have higher order polynomials. So you're going to have to find some zeros of some polynomials and list out some possible rational zeros. So remember, when you're listing possible rational zeros, this number here goes on the top, or factors of it. This one goes on the bottom. So possible zeros for this one, starting with the whole numbers, the factors of 2 are just plus and minus 1 and plus and minus 2. Now the factors of 6, there are more of those. So I have plus and minus 1/2, because 2 is a factor of 6. I have plus and minus 1/3. 3 is a factor of 6. And I have plus and minus 1/6. Now looking at the 2, 2 over 2 gives me 1, so I already have it. 2 over 3 is not listed, so I have plus and minus 2/3. And 2 over 6 is 1/3, already listed there. So here are all of my possible zeros. Be careful of instructions on the test. This one says don't find the zeros, so you would have been wasting some time if you went through and found them all. For this polynomial, I want to list all the real zeros and their multiplicity and tell whether it touches or crosses at each one. So let's make a little chart. So here I have the 0. Multiplicity for that 0, and touch or cross. So if I look at the first part, 1/3 x to the 4th, if I set that equal to 0, I get x to the 4th is equal to 0, or x is equal to 0. So here is my first 0. Multiplicity, remember, is the power, and whether it touches or crosses is based on that multiplicity. So even numbers touch, odd numbers cross, which means that this thing would touch at that 0. I'm going to skip over the middle one and look at the last one here. So x minus 3 gives us 3 for my 0. There's no power showing, so I have a multiplicity of 1, and then it's odd, which means that it crosses. Now the middle one is a little bit of a trick question because we already think that it's listed out and factored, but this thing can factor further. Notice that you have a squared term on the inside. If I were to factor x squared minus 3, it's the same as saying x plus the square root of 3 and times x minus the square root of 3. So I've got two zeros from that. One is the square root of 3. It's got a multiplicity of 1 and it crosses. The other one is negative square root of 3. Again, multiplicity of 1 and it crosses. Now if I were thinking about actually graphing this thing, I'd need to take into account what the total degree of the polynomial would be. So if I'm looking for total degrees here, I have 4, 2, and an understood 1 7th degree function. Remember, any odd degree function looks kind of like a cubic, so I would expect it to look something like that going in. Now the square root of 3, if I were to approximate that, somewhere between 1 and 2, 1.7. So looking at a graph of this particular polynomial function, my zeros are at 0, at 3, and plus and minus about 1.7. So I've got one here, I've got one here. I know based on end behavior that it's going to look somewhat like a cubic function, so I'm going to come in from the bottom. I'm going to cross at everyone except for the origin. So which means I come in from the bottom, I cross here, origin I'm touching, so I bounce back, cross, and cross, and then it would exit the axis like this.